Welcome to the AAS YouTube channel and another episode of AAS's Journal Data Series. My name is Mubdi Rahman, and I'm joined here with Frank Timms.
Hi, everyone.
Frank, how are you doing today?
I am doing fantastic today. It is a warm, sunny spring day in Phoenix, and I am in the middle of writing a software paper, so all is very, very good on my world.
Well, I'm glad that it's warm. It's slowly warming up here. It's April here in Toronto, so we're starting to get green again a little bit, piece by piece.
Yay.
But I am looking forward to seeing that software paper, hopefully, of yours as we send it through the editorial corridors.
You might just see it. The plan is right now is to submit it on August 2nd as our plan, so we'll see where that goes.
Fancy. And let me ask, Frank, how did you learn how to write a software paper?
Ooh. School of Hard Knocks, I will say.
School of Hard Knocks. Well, we're here to change that today, right?
So I started putting software elements in appendices of science papers that I was doing even when I was a grad student, right? So this is before GitHub, before SourceForge. I was putting in...
Oh, SourceForge is already going to lose a lot of our audience. They won't remember SourceForge.
I won't go there. Yeah, and so we've changed in the journals over time from people having to cram something into an appendix, which was actually a piece of software source code or describing what it was, to where we are now, where we actually encourage and welcome software instrument papers. And so yeah, my process has just been one of a long one, writing various things. So yeah.
Well, hopefully we'll be able to help people not have to go through the School of Hard Knocks to write their first software papers.
Indeed.
And so that's what we're talking about here today. We are talking about how to write a great software paper.
Okay.
Now, for those of you who don't know what a software paper is, I recommend you go to the previous episode of the Journal Data Series. We have, right in the YouTube channel, you can take a look. We cover what a software paper is. But now let's say that you've written some software and you want to get that paper out there. You want to write software paper. How do you actually go about it?
Yep.
That's what we're here to talk about.
Cool.
Let's
submit your software papers, people. Okay, how to write a great.
That's right. So it's not we're not aiming for mediocre software papers here or good software papers. We are aiming for great software papers, and that's what we're here to talk about.
Indeed.
So let's start off with what a software paper is. Again, feel free to head back to a lengthy description that we have in the previous episode of the Journal Data Series. But just nominally here, a software paper is a peer-reviewed paper in one of the AAS journals that we're talking about. So AppJ, AJ, AAS, our AppJ Supplement Series, AppJ Letters, or the Planetary Science Journal. That describes a software product that is used in aid of research astronomy. It doesn't have to necessarily have already been used, but if you are doing research or if it's intended for research, you can write a software paper on it. But here's an important question. Why would you want to write one? Let's start with that. Because, before you dump it, as we know, writing a paper takes time, right? Frank, how long do you think it takes you to write a paper on average? You don't actually have to quote that number because I know my number is going to be embarrassing. So,
from these days, from when we say go to when it's submitted is typically an 8-9 month process.
That sounds very familiar to me.
Yeah.
If a little lighter on or a little quicker than sometimes it is it takes many. All I'm trying to get at is it's a massive investment of time to decide to write a paper, right? And we all know that, and especially when it comes to importance.
Time.
Yeah.
Black hole time machines is our paper.
Yes. And an attempt to try to learn how to how to not be distracted, at least for me, and that's been the biggest thing for paper writing for me. But we're not going to go into that at the moment. That's not what this particular episode is about. But all of this to say is that writing a software paper is a significant investment, right? Writing any paper is a significant investment. So there's got to be good reason for you to do it. And there's a lot of good reasons to actually write a software paper. And the first one is you've written the software already. You're using that software. That software is being used for science. A software paper is a way of getting credit for that software. Right? This is a peer-reviewed publication that goes in your CV that, gets, tagged along with every sort of proposal that gets cited by everyone else who uses that software or results from that software. That is all in there. And these can be some of the most cited papers that there are out there. If you think of, for instance, a very, very famous current software paper that just I think is the default site for so many people these days is the AstroPy software paper, where that has gotten thousands of citations just in the couple of years since it's been published. And let me actually tell you that the software paper for AstroPy was published well past AstroPy first was developed and people started using it. So there could have been many more citations well before that. But this is a great way of making sure people know what you have put out into the research community and being able to get credit for all the hard work that you've done and you've contributed to astronomical research as a whole. Because let's be real, software is science. Without software, there is no science, and you should be able and be proud of what you've been able to do on that
You
front.
should absolutely be proud of what you've done. And also, software, just sort of the demographics of papers, right? Software papers, good ones, tend to have very long lifetimes.
Yes.
They will keep going and going and going because people use them. As opposed to, and this is, I'm generalizing a bit, but the typical citation pattern of a science paper is it gets a whole bunch of citations in the first 2-3 years and sort of the impact factor window, right? 2 to 3 windows. And then it sort of dries off. And by year 5, it's pretty much self-citations
Right.
going on after that. That's a very typical science paper. Whereas a software paper can just keep leveling out and keep going and going and going. So,
and arguably a good pattern, right? We want science to improve so sufficiently that your paper after 5 years is not the latest and greatest in that particular field, right? Like that's a good thing.
That's right.
But the software that you use to build it, that's going to be there, as you point out, for a much, much longer time.
It's just like a hardware instrument.
Yep.
Right. In fact, I call them software instrument papers. Like a hardware instrument, you build a telescope or you build a spectrograph, it's going to sit on that telescope for 30, 40 years.
Yes.
And we even have little things, hardware facilities, where you can cite the hardware facilities. And the same thing with software. That's why we have a /software these days, where you can cite your software instrument papers and they will just keep rolling. Lots of great reasons to write a software paper.
Yeah. One of the other things that we wanted to bring up in terms of why you'd write a software paper is if you want people to start using it, right? If you want to have people going out and actually using and playing with the software that you created, as we pointed out, you should be proud of the software that you created. And one of the great ways of being able to show that off is other people using it for their own scientific results. That is always a great way for people to really appreciate the work and the effort that you put into that software piece.
You are having an impact. Your software
That's right.
is having an impact.
Very much so. One of the lesser things that often you think about, but is actually super important when it comes to why you might want to write a software paper, is because these software papers are peer reviewed. It allows you to lay out the scientific choices that you made throughout programming your software and building your software, and has somebody else look at them and try to scientifically determine whether or not they're valid, if these are good scientific practices. And you get that commentary, you get people actually looking into your methods that are often really hard to do if it's just in one massive scientific result paper, right? A software paper, the dedication there is towards what is the software and what is the validity of the software that's coming out there.
Absolutely. Very cool.
And the last point that I just wanted to throw in here is that one of the great things about software papers is it's a great way of increasing the community who might help. right? Because at the end of the day, oftentimes, especially if you're releasing your code open source and you want that open core, saying that your code is open source is a good first step, but it's not sufficient, right?
Correct.
You need, like, having a software paper that people are engaged with, and having software that people are engaged with is one way of, if their results start to depend on that particular piece of software, they may start helping. They may start being a part of that community, and that makes your software so much better and helps you with your scientific results in the long term. So software papers are a great way to start building that community.
Correct. Absolutely. Very good.
So now that you want to, and we've convinced you that you really want to write a software paper, what does the software paper actually look like? And the answer is there's no one software paper. Oftentimes, like, there's no one science paper. Let's be real about this. There are many different ways that one could write a science paper. And as such, there are just as many different ways to write a software paper. So a lot of what we're going to be focusing on are sort of key points to address in the paper, as opposed to specific structure or specific nomenclature or ways to do this. And as is important to point out, there are different types of software paper based on the different type of software that you're creating or that you're wanting to get out there, right? For instance, if it's just a very small modification, a small but important modification to existing software, maybe it doesn't need a full software paper. Maybe a research note is the right way to do it.
Right.
If this is something that is very technical and very in-depth, one can think of, for instance, a new way to solve, the hydrodynamic equations, or a, pipeline that is going from individual, images or individual photon counts from a specific photon counter to the scientific data. That's going to be a much longer one. And maybe you want all of that stuff to be in a longer paper, and the supplement series would be fantastic for you.
Right. Perfect. Perfect.
So there's a large range of what a software paper could be, what journal you send it in. But all we're saying is that we want it, and we want to help you write it, and we want to help you publish it. And this is what we're here for.
We like to help.
We do. But let's go into a little bit of what are the key elements that you probably want to include in a software paper, regardless of how you exactly structure it, and regardless of how long it is, and regardless of what journal it's in.
In the venue, yeah.
Actually, before that, let's talk about what it's not. And we talked a little bit about what it's not in the previous video. But one of the key things that I want to emphasize is that your software paper is not your documentation.
Right.
This is not a list of configuration parameters of how to run it, of how do you install it, where that's not what this is for. In fact, you want that to be in a more detailed place somewhere else.
Read the doc.
Exactly. One of the, especially for open source software, read the docs is fantastic. And there's great places to put that. But it's also important because documentation should be evolving as you fix bugs, as you increase, change features a little bit, or, have it compile on different computers or different systems. You want your documentation to change. You don't necessarily want your software paper to change.
Yeah.
So just, key distinction, a software paper is not documentation of your software.
Absolutely. You will hear from the editor and referee if it is.
That's right. That will be almost immediately sent back to you as saying,
that's a doc.
From this, yes, that is a documentation, focus the scope to a software paper.
Correct.
But some of the key elements that you'd want in a software paper. So first off, what science is the software helping? Right. At the end of the day, a software paper is about software that is dedicated to helping astronomical research, either already published astronomical research or astronomical research that will happen in the future.
Yep.
So you want to describe that use case. What is the novelty or the special thing that you're doing here? Maybe it's using some new technical technique. That's great. Right? If there's if there's some software that already does what you're doing, but you're implementing a different technical technique because it makes it faster, it makes it scale better, allows you to run it in different ways, that's great, right? That's fair to describe. It doesn't have to be completely new science that you're doing if you're doing it in a different way. Right. There are many different ways to figure out if an extrasolar planet exists around a star. Doesn't mean that just because you've seen it one way, the other way is not publishable. You want both. You definitely want both.
You want both.
So this is that same idea. So just because you're writing a tool that does something that somebody else does, it's actually probably really good to have a software paper, because
Okay.
then you can actually do the comparisons. You can actually have, the scientific verification of this is what was previously the best practice, and now this is what you're proposing and what you're doing in your case. But
And
secondly, sorry, go ahead.
no, go ahead. Go ahead.
I was going to say, but secondly, there is a possibility that no one's done this particular technique before, or this is opening up a completely new science corridor, or dealing with a new type of data that no one's seen before, right? You can imagine there are a ton of software papers that we're hoping to see come out of, the EHT, the black hole, all the algorithms that were used to create the first image of a black hole, right? That's science that no one's been able to do before, and there are different specific algorithms that are coming from that. And a software paper is a great way to remove the science result, which has its own questions in the refereeing process and has its own things that you want to look for in the paper,
Right.
from the techniques that are used to create it.
Right. Very good. And just a helpful hint for authors here, it's always useful when you write your software instrument paper to be explicit about what science is this software helping. The novelty of this article is, and then where does it apply? It's going to help find more FRBs at a chime, for example.
That's right. Yeah.
For example.
Just for example.
but be explicit about what the science is doing and how the software is helping that science.
And certainly that doesn't limit the software paper, right? Just because you have a specific science use case doesn't mean other people can't use that software for other science use cases, or you might use that software for other science use cases. In fact, it'd be great if you did.
If you did, because it's actually wider than what the original design intent was.
That's right.
More people are finding it useful than what the original intent was, and that's a good thing.
That is a wonderful thing. So the next thing you'd want to cover in a software paper is talking a little bit about how the software is built. So again, not documentation, not deep, you're not putting large amounts of source code in your software paper. That's something that we will probably not look kind on as editors if you have just the entire source code dumped into the paper. But what we're talking about here are things like, what were the different choices of the software tools that you made? For instance, what was the programming language that you used? Why did you use it? What is the data formats that you use? Why are you choosing those ones? Are they the most common ones, or is this a new one for some particular reason? And what are the scientific choices behind all of these? What are the different algorithmic scientific choices that you make? For instance, when it comes to a hydrodynamic solver, there's a variety of different algorithms, and the algorithms affect what the output result is, right? You can think of using different partial differential equation solvers for different reasons, and your problem that you're trying to solve needs this one, and this is the reason why. So that's what you want to describe here: is how is all of this built and put together.
And just to follow that on a little bit, sometimes a software instrument, for example, if you're doing fluids, will have many different options for different algorithms. And so you don't have to pick one for the community if you don't want. If your software offers multiple options of ways to do it, that really helps with verification. I'm going to run the same problem with 4 different methods, and do I kind of get the same result on robustness? So options are good in community-driven software.
That's right. Yes. And the goal of the paper is to be as flexible as the software that you write inherently.
Right. Remember, you're writing a tool, right? It's not an answer.
That's right. That's right.
It's not an answer. You're providing a tool for people to search.
But that naturally leads into the next thing, which is, what are the algorithms that I'm using and how are they implemented, right? Software at the end of the day is just a series of instructions, right? You are telling a computer to do something much more accurately and much faster than you could do by hand, right? That's in essence what all software is, and it's a key part to how we do science these days. But what we're trying to get in the software is, what is the stages that the data goes through, or the simulation gets created, and how do I actually go about using that particular algorithm, or what are the choices that I made in that algorithm? In some cases, there are no choices, right? In some cases, they'll be just very, very straightforward. I summed these 2 things together. There is no, unless you're doing it wrong, there's no big
well, even that
challenge there.
little, right? So if you're adding
That's
numbers that are, large and opposite signs, and you're trying to pull out the difference between those two,
yeah, okay,
just adding
fair.
numbers can be challenging.
Agreed, yes. And I've actually run into that very issue before.
Yes.
But in many cases, there are going to be different ways to actually implement these
How to handle that.
particular algorithms.
That's right.
And
That's right.
why would you choose this particular way over this particular way for your scientific result?
And oftentimes in a software instrument paper, this is where you'll inject a verification plot.
That's right,
So
yes.
how do I compare this algorithm versus another algorithm, or the speed at which I'm going? But this is often where you will put your verification or validation, as the name,
That's right.
Algorithms in there. Yep.
And the other aspect of this in this section is some of these are going to be scientific constraints, which are great and you want to describe. Some of these are just going to be technical constraints, right? Some of these you're going to choose an algorithm, choose implementing an algorithm, even though you know it's not inherently the best way of doing it, but because you can't have 50 trillion terabytes of RAM. Right, like these are specific things that happen just because of the the computers and the technical need of the project or the speed that you have to attain it. Those are real constraints too, and you want to describe that. But you also this gives you a chance of saying this would be better, but because of technical this algorithm would be better, but because of technical constraints or the speed that we need to process it, we need to do it with this algorithm.
Or for example, a particular code may scale linearly with the number of processors, so it has perfect scaling up to some number. Could be
right.
processors, 12 processors, and then the curve sort of flattens out as you increase the number of processors. And your algorithmic choice, because most people who might be using your software are going to have less than 20 cores, this might be a very appropriate choice for the community that you're trying to hit. Right? They're not going to be running 100,000 cores. That's a different set of algorithms you may choose to put in for that.
Agreed. A good example, actually, I love of this is a classical Slant Digital Sky Survey example. So back in the early days of the Slant Digital Sky Survey, they were ingesting data as quick as it could be processed, right? So you needed to make the photometric pipelines as quick as possible for the hardware that was running there.
Yeah.
And so, for instance, in fact, you can still see remnants of this in the Sloan pipeline, or in the Sloan data. But one of the things that they need to do is actually measure the size of the object that you're looking at, right? What is the size of the source on the sky, right? If it's a galaxy, if it's a point source, you'd hope that'd be kind of point source like, and you'd roughly know what the size is based on the seeing that night. But if it's a galaxy, it could be any, random size.
Right.
And so what they had to do is they know that the vast majority of their data is going to be of order, arc seconds in size. Right. And so they have a very specific algorithm that looks for the size and refines on that.
Got it.
But they know for certain objects in certain weird cases, that algorithm is going to fail because the object's larger or because of noise. Yeah. But you don't necessarily, but you know that you don't care about these very, very large things inherently in the same way that you care about your, typical galaxy.
Okay.
So what they did is they just put in very specific size limits. And so you can actually see, if you look at some of the largest objects in the Sloan catalog, they are actually at very, there's a ton of them that are just at these very specific numbers of their size, because that was the quickest way of processing that data and getting through it, because it's not going to be reliable at that size anyway. And so that was a decision that was made based on technical constraints.
Magic numbers.
Exactly. Yeah. Everyone who's downloaded a table from Vizier and dealt with negative 9,999 knows this exactly.
Indeed. Yep.
But now let's say that we've gotten these algorithms, you've written them down, you've tried to implement them, and you've described how you implemented them.
Okay.
One of the natural things will be, how do I get the software? Now, just a little note here, a software paper doesn't necessarily mean that you've made your software public, right? Just there's a variety of reasons that your software may not be public. It may that you don't have permission to make it public, or for instance, government labs are a good example where you cannot just let this random nucleosynthesis code go out to the rest of the world. Inherently, there's proprietary reasons that you have to keep it, or security reasons you have to keep it within that. But in the case where you are encouraging people to go use your software, one of the things that you want to describe is how do you actually go about getting this software. One of the things that is very common practice, and we encourage you to do at the AAS Journals, is use Zenodo. So Zenodo, especially for open source software and anything that's in on GitHub, for instance,
Right.
there is basically a 4-button sequence where what it will do is we'll take that current version of the software and basically encase it for all of time. So that exact piece of software is actually citable, and the exact version right there and then, and it can be connected directly to your paper.
Yep.
So that is something that if you submit a software paper, that will likely be one of the first comments that you'll get from the data editor is go to Zenodo and create a specific version release of that software that you can tag directly to that paper, and we'll do all the cross-linking for you.
Cool. Very cool. Okay. Do you want to get it?
So the next thing that you want to do is show me how the software helps me solve a problem. So this is, typically you're building software to solve a problem. So actually take me through the procedure. Even if it's a toy problem or if it's an already solved problem, show me how you actually use the software to solve that problem.
Yeah.
Right? Give me, as Frank, you were talking about validation tests. This is a good place to, put in a ton of validation tests of, this is what other software does on this particular data set, and this is how my software improves on that, or does it quicker and at the same level of accuracy, or does it quicker but has a tolerable difference in accuracy. These are all things that you can throw in there, and gives you the ability to, show why the software is important, how the software is novel, why it deserves being published.
Yes. Showing it in use is a good thing. Living papers. Go ahead.
Yeah. And so one of the things that we recognize when it comes to software is that software evolves, right? It should evolve. Right, computers evolve, science evolves, so should the software that's doing all of the science and underlying all the science. So one of the things that we have, and we're really excited about here at the AAS Journals, is living papers. So it's a new type of paper where you can add on to a paper that's already been published. So a software paper can be a living paper in the sense that you can add on sections. Let's say that the code evolves significantly. You can add on an additional section which will go through its own separate peer review. Yes. That section. You can add on additional authors. Let's say that the people who have developed the software have increased, and your software has become much more broadly adopted by the community, and so other people have contributed to it. You can start to give them credit in this next version of the living paper. And the living paper can continue to grow, and each version of it gets its own citable link. So let's say that somebody is only using the first version of your software. They can cite that first version of the software paper. Let's say that they're using the second version or the third version. You can give them specific links and ways to cite that is to a specific publication, and all of those citations go and give your software and you the credit for all the work that you've been doing and everyone else subsequent from that. Cool. So it's a great way of really, when you don't necessarily need a completely separate paper on that software, it's just an evolution of the software over time, you can have your software paper evolve over time as well. Cool.
Very good. And sometimes, just to count that, sometimes a completely full new paper is appropriate for.
Yes, entirely.
Significant, changes or additions or capabilities added, then that's worth a second paper.
That is entirely worth a second paper. That's right. Yes.
But living papers are a fantastic idea, and I'm excited to see them work.
Yeah. And especially what it does is it does take down, like as we were talking about, papers are a large investment.
Yes.
And so this takes down the sort of activation energy to get you to update that paper and to give you the ability to create something citable.
Very good. Very good.
So yeah, one of the things that we at the AAS Journals really love is open source software. Open source software is fantastic for being able to provide it to a large number of collaborators or a large number of the members of the community who would potentially want to use it for their own software research. But also it's critical in helping your software or your science be reproducible. If you want to reproduce that same result using the exact same code that was used to do it is an important part of it. And note being that we don't require open source software for a software paper. If you have a variety of reasons for your software to be proprietary, that's completely fine. But we do encourage it. Open source software is a fantastic practice for scientific software. one of the partnerships that we have here at the AAS Journals is with the Journal of Open Source Software. And that is a journal in a very new and unique sense. What they do is instead of, so as a traditional journal, we take manuscripts and we deal with papers. What the Journal of Open Source Software does is it looks at code and tries to, and does a peer review on the code for coding standards. So it's a great way of having somebody go through your code and be able to tell you, look, this is a better way of, dealing with these configuration files. This is a better way of citing certain things or implementing certain things. And it peer reviews the code for you as well. You certainly don't have to do it, but you can. And we have a great partnership that if you submit your software paper with the AAS Journals and your software at the Journal of Open Source Software at the same time, we can coordinate for you and have both of those things come out at the same time and get published together and be linked to one another. And importantly, the Journal of Open Source Software is a community effort. So it's a lot of people who are volunteering their time across the software community, not just in astronomy. And one of the things that if you publish a AAS journal article, a peer-reviewed one, the Journal of Open Source Software actually gets a financial contribution for this. So it's another good reason to publish both the software paper with us, but secondly, to make use of this opportunity for the Journal of Open Source Software.
And for authors, it's a twofer.
That's right, exactly.
You get a twofer. Rarely do you get to publish twice. In fact, you never do. But
yes.
Here you get to have two citable links for your one piece of work. So that's right.
Yeah, that's in a nutshell what I would recommend in terms of writing a software paper and writing a good software paper. It's more than writing as a good software paper, writing a great software paper. That's what we're here about.
That's right.
But the key things to remember and to take from this is remembering that it's not documentation.
Right.
That it's that you want to describe the science that people can do with it and go through the scientific and technical choices that you chose to make the algorithm and make the science happen. And give us some examples of how your tool helps do the science that you say it's going to do. That in a nutshell is a software paper. Frank, anything you want to add to that?
You have motivated me so much that I need to go get on my software paper right now.
Well, I am looking forward to seeing that software paper.
I'm bothered.
Fantastic.
I gotta get it going. That was awesome, Mubdi. Thank you so much.
Thank you so much, and thank you so much for letting me do this. And also, one thing I want to spread out: if you need help or if you have questions, please feel free to reach out to myself or any of the editors at the AAS Journals. We are here to help you, and we will be happy to sort of take you through the process and consult with you on what a software paper looks like and helping you get your own going.
Absolutely, very cool. Well, thank you for that offer. Awesome.
Awesome. Well, that's what we have in a nutshell. Again, feel free to reach out, but thank you so much for joining us on this episode of the Journal Data Series.
Bye-bye.
Bye.